So this is my own home private observatory, which I constructed in the fall of 1999. It is 8 feet square and was constructed for about $1,065. The entire structure is supported by on the corners only, and the floor floats across from that. We don't want the floor to touch where the telescope stands, so that the vibrations of walking around would affect the stability of the images. Of course, we need a roof to disappear, and so as you'll see in a minute, this will roll off, opening the observatory to the night sky. I've just released the roof. It is attached on wheels that roll out onto the tracks. When the roof is in, it's pinned in place with these 10 or 12-inch nails. The reason I use these is they're easy to remove, they're very strong, and they're easy to get off with a large gloved hand in the wintertime. They only go in about this far, which gives a nice big handle. So they're very sturdy. If I'm leaving the observatory for a long time, there's 12 of them that go in, but normally I put 5 in to make it safe. So here we go. We always want to do this a half an hour or more before we observe to allow the temperatures to equalize, especially in the summertime when the air is warmer and you get some significant heating in the daytime. The roof is sufficiently heavy that it can stay on that set of tracks without any problem during the session. The tracks are long enough that there's no danger of pushing the roof off. And now we'll get into deploying the observatory ready for operations this evening. So this is the observatory as it is after the roof came off without any modification. And there's a rack straight ahead when I come in. The table that I use for charts and accessories. I don't use charts as much as I used to. And then the observing chair, which is a car seat, tipped slightly forward on a base I built that I can use for comfort seating for the hours you spend doing this. And finally, currently the telescope that is kept protected under a barbecue cover, which works very nicely if there's any seepage in the roof or dust, etc., etc. Tends to keep the telescope very clean. And finally, we come around to my control center. This center was originally portable. I guess it still is. I screwed it to the wall. But when I used to set up my telescopes in the field, this came with me. This folds up into a suitcase, and I plugged this into the car battery, and this would give me 120 plus DC power, whatever I needed to run the various things I was doing. The large black item you see on the table is a dew shield. It will go on the end of the telescope, and there's a heater in it to prevent dew from forming on the corrector plate. So now that we're sort of configured, here's a bit of a tour of the observatory. First, over the table, we have the computer here. Currently it shows the star map that I use. You notice that everything's in red, and this is because it helps my eyes in the nighttime. And we'll get back to this later, but these circles are the amount of sky that I can see through the photometer. So this helps me hop from one field to the next so I can find my way without having to think about it every time. However, that's sort of a backup system, because if the computer's working properly, it will tell me exactly where my telescope's pointed. I'll show that later when it's actually operational. Now this program also has, this computer also runs my observing records software as well, and also a data sheet indicating which stars I should observe and so on. So these things are all part of that, so I can switch back and forth and so on. Also here are the temperature and humidity. There's some reminder aids, so certain key presses I can use on the computer. Storage here on the top. Those are bug jackets. Astronomy outside, although obviously we only observe during clear weather, is still quite a difficult undertaking sometimes due to the mosquitoes or the significant cold that you get in the wintertime. You can't heat the observatory because the heat as it leaves will disturb the air in front of the telescope. This is a picture of my first astronomy class that I taught at Garneau in 1999, and they were there when I was building this building, so they gave me this picture that had to be put in the observatory, so that's where it is. This is the plugs here for the computers and the telescope stuff and so on. Another red light here for my my own work. And then we come over here to the control center, which only has one light on it right now. So this was what I used to use out in the field to run my systems. My computer would sit on the control center. This, like I said, the top folds down, and underneath are legs that fold up and so on, and that becomes a relatively heavy suitcase, but it was very effective. Those arms that you see right there, those would fold out, and I put a small blue tarpaulin over it, and that would keep the dew off my computers. This main switchboard that you see here in the front is designed to select power for the different parts, accessories I'm using tonight. And the primary one I'm going to be using, of course, supplies power to the telescope, and it supplies power to the heating system that keeps the dew off of the corrector plate. We then also down here, although it's a bit dark right now, but you can see this device here is my stellar photometer, which is currently warming up. Now it probably doesn't need this much warm-up time, but it's going to be later attached to the telescope, and it'll be this device that will give us the measurements of stellar brightness that we're interested in. I mentioned earlier that I had a device that would tell us where the telescope is pointed. The computer is in this little tiny box here, about the size of a cigarette case, and there's encoders on the axis of the telescope right up here, and also on the declination axis right there. And those feed to that controller, and then that information is sent to the computer. Now the telescope has been taken out of its cover, and you can see it there now pointing at the night sky. Remember that the dew shield here is not part of the telescope. The telescope goes from here to there, and the light passes through it 3 times before it comes back out here to the focus area. Now what's at the back of the telescope here is first a mounting collar, and then this focuser system, which allows focus to go this way, which prevents images from shifting back and forth, because if you use the primary focus on this type of telescope, you're moving the primary mirror back and forth, and if that rocks even slightly, your images will move. So that's been one addition, but it does make the thing longer, and with the photometer in the back, that does make a problem. Here is a star diagonal, which allows me to look this way instead of having to look this way. Much easier to use. And then on the top we have 2 pointing accessories. This one, which is used a great deal, is called Telrad. It is a reflex sight which allows you to see where the telescope's pointed by looking through a projection of a set of rings. Now let me see if it will record on the camera. So if I turn them on full blast, there we go. There you can see the rings there now. Now the nice part with this is because they're a projection, it doesn't matter if you're lined up, if you're like this or that, it doesn't make any difference. The star that you're looking at, if it's bright enough, will be right there as you hope it would be. And we have to remember to turn them off. Over here is the finding telescope, which is the same size as a set of binoculars. I hardly use it anymore because the Telrad allows me to align on 2 bright stars, and then the computer does the rest. And so this has been good because the telescope's fairly high in the observatory, and I have to get up and down a lot, and it was very hard on my knees. And then we come around, there's the door we used to get in, and we come around here to the accessory table, and here are my eyepieces, which I use only in the beginning of the session to have a look. Now I did bring out also my old star charts, which I haven't used now probably in 7 or 8 years. When I first bought this telescope in 1990, these were just coming out, and this was the way to do it. So there were 438 of these charts, and the stars that you see on these, every dot is a star. The bigger dots are brighter, and so on. And these stars, all these stars will be visible in a set of binoculars. And in this book, there's about 280,000 objects listed on this catalog, maybe 300,000. Now that sounds like a lot to the person who doesn't do this. However, a telescope such as the one to my left probably can see somewhere in the neighborhood of 12 million. And a lot of times, if you're in high magnification, you can't find yourself where you're going in the sky. The computer program I use, called Guide 8.0, has 18 million objects in it and has access over the internet to 500 million. And so, although I don't use equipment that would get me that dim, the capabilities today are just phenomenal. Now, telescopes such as this one, right now this drive system here has a slow motion in both right ascension and declination axes, and has a clock system that times itself with the star time, and it works very well, very dependable. And here's the hand controller that I use to speed up and slow down. You'll hear the motors running in the declination when I use it during the session. And today, of course, everything's computerized. So this was a telescope purchased in 1989, and of course, by 1994, 95, 5-6 years later, they came out with the fancy computer systems. So now you can literally click on your page, and the telescope will actually move to the site of interest and be there probably within an arc minute or less, depending on how well you've calibrated it. So that's a tour of the observatory. Now tonight, tonight's objective primarily is astronomical photometry, which is the primary work that I do here in the observatory. And this involves making very precise measurements of stars selected by professional astronomers that require monitoring on a regular basis. Now, I'm not the only one, of course, doing this, but the people as part of this group, there's about 50 of them at different times, who make these observations, together allow for more precise observations of stars whose brightnesses fluctuate only a small amount. And this is where we need the photometer, which I originally bought for my work during my undergrad when I was measuring asteroids. So what we'll do now is we'll wait till we get a decent alignment, and we'll show a brief segment while I'm actually using the equipment in the observatory. The lighting, of course, will be necessarily low, but we'll have a chance to see this. So the telescope's not configured. It's actually not as dark as it appears in the video, but what I want to show you, this is the readout on the photometer's numerical display. It's looking at the night sky. When it's completely dark, this would read around 700. But what you see now are the numbers slowly going down. They'll change every 10 seconds. And this is actually the sky getting darker as we speak. Imperceptibly to humans, but certainly not to the machine, as you can see it going down. This is real and not an illusion as we go down. Now probably below, there we go. So in another 5 minutes or so, we should be able to begin operations. So as you can back up from here a little bit and see, the observatory has its red glows, and better the computer screen over here is a typical display I'm using now when I'm observing. The field of the star I'm interested in this is the star CH Sig. And right now you can see the crosshairs there. That's exactly where the telescope's pointing. That's a live connection to the computer. And this star is the comparison star, so we'll measure it. Then we'll come over here to the variable CH Sig. We'll measure it back here, then here, then here, then here, then here. And that gives us 3 measurements of the variable and 4 of the comparison star. You always want to bracket. And then we'll go over here, outside of the view, to the check star, just to make sure we haven't made a mistake. I lied. The check star is over here. So we'll go down there when we're done. Now this star is actually quite a symbiotic star, so it's actually very interesting because it's kind of unpredictable. So a lot of people are looking at this one, and it's the kind of star that you want to observe just about every time you're out. Now, just to show you some dated arrangements, this particular program here was written back in the 1980s and still used to, I use it at least at the telescope. It works fine for me to type in my data. And then now, of course, you can just send your file over the internet and immediately it gets posted on the internet, as I'll show you in class. So there's some neat things. And regrettably, the clarity, don't think it can focus, unfortunately, on the characters, but that's no big deal. We can show that in class. Okay, so that's it from the David Raymond Memorial Observatory, and hopefully you've enjoyed your little visit here tonight.